All right, hey guys, this video is going to go over solving equations. So our learning goal for today's lesson, we're going to be solving equations with variables on both sides, okay, which you have done last year. So it's just going to kind of be a little refresher. Hopefully by the end of the lesson or the end of class today, you can solve an equation with a variable on both sides. You can also write an equation that has variables on both sides. And you can solve an equation that has a fraction bar. I'm going to add one more learning goal to this. Hopefully you can also check your solution to your equation by the end of today. All right, so let's go ahead and start with kind of solving an equation with pictures. So I want you to think of letter A as a scale, like a balance. So both sides are equal. We want to figure out, well, what do one of these squares have to equal so that the sides are balanced? So on this side, I have a -1. Over here, I have 2, 4, 6, 7. And then, I've got a couple squares on each side. So if I'm trying to balance this out, here's kind of what I think of in my head. I think like, hey, one of these squares, that's the same as that side. Okay, so now I have 2 squares, and a -1 is the same as 7. When you were first learning how to solve equations, you kind of thought to yourself, all right, I want to get rid of that -1. What if I added 1 to this side and added 1 to that side? It would still stay balanced. This would just be gone now. So now I have 2 x's are worth 8, because I have 8 green ones over here now. So one of them would have to be worth 4. Then it would be balanced. So that's kind of how, when you first were learning how to solve equations, you can kind of think of it like a balance. Now we're actually going to solve some. So here are some solving equations reminders. If you want to put this in your notebook, you can add these hints or reminders. But when you're solving equations, remember, you need to keep your equation balanced. Whatever you do to one side, you have to do to the other side. So that's super important. Always simplify first. Today you're going to see some problems where we need to simplify first before we can solve. The next thing I always do is you want to get the variables on one side. And I always try to get rid of the smaller one. And you'll see when we do a couple today what I mean there. Then you want to get the constant numbers on the other side. And then you go from there to solve it just like we were doing yesterday. So let's go ahead and solve this first problem. Again, you don't need to do this in your notes. You could do it in the back of your notebook, wherever you want. These are just your examples. So I'm going to draw my line down. First thing I check, is there anything to simplify? Okay, well, if I'm looking, there's no like terms over here, no like terms over here, so nothing to do. Next thing, I see variables on both sides. I want the variables to be on one side. It doesn't matter if they're on the right or the left. So what I do is I look always for the smaller one. So I see 2 is smaller than 5. So if I want to get rid of a positive 2x, I can add in a negative 2x, or just subtract 2x from here and subtract 2x from this side. Okay, I like to draw my line. Those are gone now. Over here I have 3x minus 8 equals 10. Now these are just like the ones we solved yesterday. You want to get the 3x by itself. So opposite of a -8 is a positive 8. So I'm going to add in a positive 8 to both sides. That makes 0. I end up with 3x equals 18. And you guys know the last step, opposite of multiplying by 3 is dividing by 3. I end up with x equals 6. So I just solved a multi-step equation that had variables on both sides. So let's try another one. Okay, so again, this can be in the back of your notebook, unless you feel like this is one you want in the front. And first thing I need to do is always look and see if I can simplify. All right, well, I do see I can simplify, so I'm going to distribute the 2 to both sides. All right, so if I do that, I end up with 2x plus 8 equals 10x. All right, now I see that I have variables on both sides. I want to move them so they're on the same side. So I'm going to try to get rid of this 2x because that's a little smaller. So to cancel out a positive 2x, I'm going to add in a negative 2x to both sides. All right, and when I do that, that's going to cancel. I'm left with 8 equals 8x. And then last step, opposite of multiplying by 8, divide by 8. I end up with x equals 1. All right, now let's do a check on this one to see if we are correct. So when you do a check, you need to go back to the original equation. Okay, and I'm going to rewrite it. And instead of an x, I'm going to put a 1 there, plus 4, and then it says equals 10. Instead of x, I'll put a 1. So now I'm just going to make sure that both sides are equal. Think of it like a scale. If both sides are equal, then I know I did it correctly. So I'm going to do 2 in parentheses, 1 plus 4 is 5, equals 10 times 1 is 10, 2 times 5 is 10, 10 equals 10. That is true, so both sides are balanced or the same. So I know I did this correctly. My answer is still x equals 1. My check is just saying, yep, both sides are now equivalent. So let's go ahead to our next one, and let's draw our line down. So this time we have one that has a fraction. This would be maybe one that I would add to my notes if you wanted to have another example in your notes on your equation page. So first thing, I see y's on both sides. I can't have that. Now, I can't just try to get rid of this y up here until I undo some other things. If you ever have a fraction, you want to try to get rid of it. So I'm going to think, what's the opposite of dividing by 4? Because that says dividing by 4. I'm going to times by 4. Now, if I times by 4, that is going to cancel, so I need to times this side by 4 as well. And this, I just want to point this out to you guys, this was all one big term, so that's why I just needed to times the entire thing by 4, and that would cancel. So over here, I've got 20y equals, on the other side, 12y plus 16. All right, now I have y's on both sides, so I'm going to get rid of the smaller one. I'm going to subtract 12y from both sides, keep it balanced. I end up with 8y equals 16, and then you guys know from here, divide by 8 on both sides, I get y equals 2. All right, I will show a check on this one, so let's just do a quick check here. So for your check, you need to rewrite the original problem. So it said 5, and then it said y, which we got 2, equals, and it said 12. Instead of a y, I put a 2, plus 16 over 4. So I want to work this out and see if I get the same thing on both sides. Well, the first side's easy, that's 10. Okay, the second side, I need to do some work. All right, on the second side, I'm going to do on the top, 12 times 2 is 24. Plus 16, and then divided by 4. So if I do 24 plus 16, I get 40. And then 40 over 4 is 10. So I got 10 and 10 on both sides. So I know my solution is correct. All right, let's try another one. This time we have one that has a fraction. And I'm going to show you a couple ways to do this, and I'm not going to check this one. All right, so first thing, I just want to point out that this is one big term over here. Now, you have two options here. You can distribute, or I want to show you one other thing you could do. You could also be like, okay, if I want to get rid of 2/3, I could actually times this by 3, because that would cancel this. I times that thing by 3, then I would need to times this by 3 and this by 3. Then I'm left with 2 times x plus 9 over here. And then 3 times x is 3x, 3 times 10 is 30. Now that's one way to kind of think of it. Then I'll still have to distribute. The second way to think of it, again, you can do whatever way you like better. I just want to give you some options. Is I could be like, all right, I'm just going to distribute this. So I get 2/3 x plus, if I do 9 times 2/3, I get 18/3. And then I have equals x plus 10. Now, if I'm that far, I still have 2/3 x plus 6 equals x plus 10. Now here's the issue with that. You still have a fraction, and it's not like the nicest thing to work with fractions. So I could still try to get rid of that fraction. I could times this by 3, but if I times that by 3, I need to times that by 3, that by 3, and that by 3, and let's just see what happens. 3's cancel here. I have 2x plus 3 times 6 is 18 equals 3x plus 30. Now let's just go back to our other one and see what happens. If I distribute, I get 2x plus 18 equals 3x plus 30. So if you look at this, I ended up with the same thing. If you look here and here, I just got to it 2 different ways. So you can kind of decide which way you like best. And then from here, you guys would be able to solve it. I'm not going to solve it the rest of the way. I just wanted to point out 2 ways to do that if you had a fraction out front. All right, let's try a different type of problem. It says I've got 2 figures, and I want to write an equation and solve it so that the 2 figures have the exact same area. So I want their areas to be equal. So I want the area of the rectangle to be equal to the area of the triangle. All right, so I'm going to try to see if I can find the area of both. So for a rectangle, you guys know the formula. If I want to find the area of a rectangle, it's length times width. So I see my length is x plus 4, my width is 5. So if I have to multiply those, I'm going to do 5 times x plus 4. I'm going to put that in parentheses because now I have my width times my length. Okay, triangle, a little bit harder. The area formula for a triangle is base times height divided by 2. So my base is 12, so I'm going to put 12 times my height. Looks like it's 2x minus 6 if you look right here. That's what that's supposed to say. And then divide it by 2. Now I have an equation. I'm just going to kind of zoom out a little bit so we can see. Now let's go ahead and distribute. So we should simplify first. I got 5x plus 20 equals over here. I want to show you a little thing that you can do on one like this. You could either just keep it like that, or right away on the top, this is all one term, I could take the top divided by 2. So if I divide by 2, I get 1 and 6. Makes it a little bit easier now. So 6 times 2x minus 6. All right, then I can go from there and distribute. And I end up with 12x minus 36 equals 5x plus 20. If I keep going, I'm going to get rid of my x's. I'm going to do this pretty quickly because you guys are pretty good at it. Subtract 5x. I end up with 20 equals 7x minus 36. Next, I want to get rid of the minus 36, so I'm going to add 36 to both sides. I end up with 56 equals 7x. Lastly, divide by 7. 56 divided by 7 is 8. So my answer is x equals 8. Now, if I wanted to actually find out how long like the rectangle is, well, this side's 5, and then the bottom was x plus 4, so 8 plus 4 is 12. And then my area, if I wanted to know the area of that rectangle, I would do 12 times 5, which is 60. There's my area. Same thing for my triangle. I know that this is 12. On this side here, the height was 2 times 8 minus 6. So 16 minus 6 is 10. So there's my height. And then if I wanted to find the area, I do 12 times 10, which is 120, divided by 2, which gives me 60. You don't have to write all of that down, but I just wanted you to try one like that. All right, last one. It says we want to write an equation for this, so I'm going to let you pause the video and try to write an equation for this. Okay, so it says 3 times the sum of a number and 4. Okay, so I'm going to do 3 times the sum of a number, we'll call that x, and 4. And it says that is subtracted from 10. So that means that amount is taken away from 10. And it says it's the same as, so same as means equal, 2 times the number, so 2 times the number, 2x, and then increased by 8, I would add 8. All right, so now I actually have an equation. When I solve this, I'm not going to solve it all the way, but I just want to point out some things. When you're solving something like this, again, you should simplify first. So I see 10, and then I need to distribute this. Remember, use that minus sign in front of the 3. So negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. And I still have 2x plus 8. And then finally, just combine some stuff. So 10 and negative 12 is negative 2, and minus 3x is still over there. Okay, then I could solve this from here. All right, so learning goal for today is, can you solve different types of equations, ones that have variables on both sides, and can you check your solution to an equation? So now you're going to go ahead in Class Kick and you're going to try some problems to see how you're doing on this.